Life is a competition. Everyone is fighting for the right to survive. And I don't just mean humans, I mean all forms of life on our planet. The Earth and its environments vary and change rapidly, so in order to survive, you need to be willing to adapt to your environment. In this episode, we're going to answer the question, why only the fittest survive? I'm Damon, and this is Astronomical. The first thing we need to understand is, where did life on our planet come from? This is the birth of our solar system. Within this supermassive cloud of dust and gas are hundreds of stars being born. Our sun is a second or third generation star, which means we are formed from the ashes of another much larger star, whose supernova remnants are now the seeds for new, smaller stars, which will live for much longer than they did. Certain areas of the nebula start to condense and produce protostars, which are still surrounded by large amounts of debris. As time passes, order begins to take hold. Some objects are orbiting in the opposite direction to the majority of others. They eventually collide, and the young solar system develops a sense of direction. This is why you tend to see almost all of the celestial bodies orbiting anti-clockwise around our sun, because if they didn't orbit in the same direction, they would crash into one another. This stage in the life of our solar system was exceedingly violent. This is the Earth colliding with hypothesized planet Theia. The collision produces an immense amount of debris, which slowly coalesces in its orbit around the Earth to form our Moon. The Moon becomes tidally locked with the Earth and gives us a steady rotation on our axis. Now, our planet was ready to become the blue planet. After a couple 100 million years, it had finally cooled enough to allow the first appearance of liquid water. We now move into the late heavy bombardment, a period in which the Earth is being attacked by countless impact events. It is likely that the thermal flux led to hydrothermal activity. Here at the bottom of our oceans, they produce the first signs of life. Our next best theory is that one of those pesky asteroids that rained down on the planet contained the ingredients for life, which under the right conditions flourished. Either way, almost 1 billion years later, photosynthesizing cyanobacteria evolves and triggers the Great Oxidation Event, leading to the oxygen concentration in our atmosphere to rise. This is when things really start to get interesting. Simple life gradually becomes more and more complex, as we see the emergence of sponges, jellyfish, and eventually crustaceans. As the fish begin to take control of the seas, one brave animal decided it had seen enough of the water and wanted to conquer the potential niche environment that was the land. This is Tiktaalik. It was the first vertebrate animal to venture from the oceans onto the land, which means it was the first backboned animal to take advantage of all the food that was out here on the surface. Because it made this transformation of environment, we are here today. Every species outside of the fish and insects has evolved from this creature. Now, as you can probably tell, although it does look very much like a fish, its fins have become limbs. These allowed it to move across the surface of the ocean floor. It would venture from lagoons like this to one another in search of new food. But whilst it did so, it made the trip across short stretches of land. And it discovered that there was a vast variety of different food sources here on land. Because of what Tiktaalik did 375 million years ago, we are all here today. From the amphibians evolved the reptiles, in which the dinosaurs were a very big part of. It was almost 200 million years ago that marked the beginning of the golden age for the dinosaurs. They ruled the planet unchallenged. Amongst them were a group of dinosaurs known as theropods, which included some very special members, like velociraptors, the Tyrannosaurus rex, and one very particular dinosaur that changed the Earth forever. This is the most important fossil in the history of science. It is the missing link. It belongs to an animal named Archaeopteryx. Now, the reason Archaeopteryx was so special was because it was half reptile and half bird. Its fossil shows that it had feathers, and this is special for one of two reasons. The first being that reptiles are cold-blooded animals, which means they need the heat from the sun in order to survive, but feathers conserve heat. They also allow for powered flight. There was enough muscle on the bones of Archaeopteryx to allow it powered flight. This wasn't an animal that just coasted through thermal pockets of air. This was an animal that flew. This is a transitional fossil. Archaeopteryx was at an intermediate stage. It overlapped between reptiles and birds, but it bridged the gap between these two. The discovery of Archaeopteryx was concrete proof of evolution. But it came 2 years after Charles Darwin published On the Origin of Species. So what inspired him? Well, it all started when he was 22 years old and he ventured to the Galapagos Islands. This is the Galapagos Islands, a volcanic archipelago 1,000 kilometers off the coast of Ecuador. It was here that a 22-year-old Charles Darwin first developed his theory of evolution. And it's because there are few places on Earth that are more diverse and abundant in forms of life. As you can probably tell, the Galapagos Islands is several complex, varying environments. Some have volcanoes that are freshly erupted, whereas others have volcanoes that have been dormant. What that means is, on the islands where volcanoes have just erupted, the soil is very fresh, very fertile, whereas the ones where it's been dormant, it is dry and almost barren, meaning that different forms of life have had to evolve with their environment, especially if they are limited to just that island. Now, many people believe that Charles Darwin formulated his theory of evolution based on the finches from the Galapagos Islands. But although they played a huge role, this isn't necessarily true. Arguably, the biggest factor in his theory was the tortoises. The Galapagos tortoise was amongst the biggest in the world. In fact, the name of the island comes from a Spanish word for tortoise, Galapago. These weighed up to 250 kilograms and were as much as 5 feet long. They were enormous. And whilst the sailors set off for the rest of their expedition, the tortoise proved very useful. They needed a food source, and these provided plenty. They had a very slow metabolism, they could sleep for 16 hours a day, and they didn't need to drink or eat for up to a year. But what Charles Darwin noticed was that the tortoises tend to have two very distinct shell shapes. For most of them, their shell shape was flat, but others had one that was more concaved, allowing their neck to venture higher from the ground. And this was because of the island they belonged to. If the island was barren and there were no food sources on the ground such as grass, then they needed to look for other food sources. And that could be leaves off branches. Now, there were obviously other forms of life on the island, which would have likely picked off the same food sources the tortoise had. But they evolved to make the most of different food sources, ones that were inaccessible to different forms of life. They had evolved and adapted with their environment. The tortoise evolved from the turtle, which came to exist around about the same time as the dinosaur. But today, we still see species of turtles in abundance. So what happened to the dinosaurs? Sometimes in life, you can do everything right in order to survive. But that doesn't mean you can stop an asteroid impact from wiping out roughly 75% of all life on the planet. The asteroid was roughly the size of London, and it practically decimated the entire animal kingdom. The non-avian dinosaurs that were over 25 kg did not survive. The aftermath of the explosion blanketed the planet in a fiery cloud of dust, suffocating most species and rendering them extinct. But amongst this catastrophe were a small number of ground dwellers. These were amongst the very first mammals. Nocturnal animals scurried around the ground at night in fear of the dinosaurs. Their time had now come, as the earth was up for grabs. With no real threats other than each other, the land was a free kingdom, one which those early mammals took control of. With the ground no longer being their limit, some species decided to take to the trees in search of more food. These were some of the very first primates. We are primates. We belong to this family of animals. There are several key moments during history where our family tree branched off, leading to a variety of different primates that are essentially our cousins. Here in the Amazon jungle live what are known as the New World monkeys. They branched off from our family line roughly 45 million years ago. But despite there being almost 50 years of evolution between us, we still share a striking number of similarities. Amongst the key factors are the two forward-facing eyes. This is a pygmy marmoset. Weighing ever so slightly more than 100 grams, they generally live in troops of between 2 to 9. In fact, some of our long-distant primate cousins still share a striking resemblance to us today.
This is a red wakari monkey.
A red wakari.
The local people here, they call England monkey. By the way.
We can trace our ancestry all the way back to the tarsian, which is an animal that resembles the pygmy marmoset in many ways. Its separation was soon followed by the New World monkeys, and then the Old World. In evolutionary terms, it wasn't until fairly recently that we branched off from the other great apes. Firstly the orangutans, then gorillas, followed by the chimpanzees, and then finally us humans. We still had to go through many different steps amongst the Homo family. Homo habilis, Homo erectus and the Neanderthals are all now extinct. But they did all show one key striking difference between their skulls, and that was that they were gradually allowing more room for a bigger brain. We have now reached the Holocene. All archaic humans are now extinct.
Now, it wasn't until 11,700 years ago that we were still in an ice age. Most of the planet was very similar to this. It was very cold, which meant that in order to survive, you had to adapt to a different environment, which many species did for millions of years. Change happens rapidly, and it always happens. We've been through many ice ages. In fact, we're due another one around about now. So those species that couldn't adapt to the melting temperatures which caused most of the ice to disappear, they went extinct. And one of them was a truly colossal animal that was pretty crucial to the survival of our species. This was the woolly mammoth.
The woolly mammoth was vital for human survival. We used its fur for keeping us warm, as well as its tusks for creating tools and shelter.
Now, the woolly mammoth was a colossal creature, but its extinction lined up with the end of the last ice age. This was an animal specially adapted to suit the cold environment. Its short, fluffy ears and tail were brilliant at conserving heat. But as the ice began to melt, this phenomenal beast couldn't stand the warming temperatures and lack of surface. Now our planet is covered in 70% water, when back then during the Ice Age, it was pretty much all solid ice. And around about this same time, when the mammoths went extinct, Max, come here. Another drastic change occurred. Over 10,000 years ago, Max's great ancestor was one of the most feared creatures on our planet. Now, a very special relationship occurred between humans and wolves. Much like humans, wolves are pack animals. They hunt together. This is because there is safety in numbers, and you're more likely to get a meal at the end of the day if you hunt together rather than solo. But some of the wolves that were outcasted became very desperate for a meal. They felt that they needed to find any scraps possible, which led them to the early humans. When they were finished with a kill, they left behind the scraps, the bones with a tiny bit of meat on them. The wolf would wait patiently, posing no threat. In fact, often acting as a guard, protecting them from any other predators that might come and try and feast on their meal. And it's because of this that the humans continue to give these wolves a steady meal, which meant they survived and passed on their genetic code to future generations. This led to future generations of more tame, docile, and trusting wolves. Pretty soon, a partnership developed between humans and wolves. Now the humans and wolves would hunt together. And this was an alliance that led to both parties prospering. It wasn't long after that we developed agriculture, which meant we could count the amount of things we had. We got to a point where we had more stuff than we needed. So our focus was no longer on looking for the kill for the day, finding the next meal. We could focus on other things, which meant wolves were no longer bred just for their hunting ability. Instead, we chose to breed them for other traits. Perhaps they had fluffier ears, maybe they were smaller, maybe they had a much more high-pitched yelp rather than a roar. The transformation of the wolves became so dramatic. In just over 10,000 years, the wolf has turned into what we know as today as the Chihuahua, which is, if anything, more fearsome than the wolf. Max here is a result of selective breeding. We chose to breed his ancestors with one another based on certain appearances. Now he is a lot smaller than a wolf. His fur isn't quite as thick and insulating. His ears bend and flop down the perfect amount, and the colour is different to the rest of his body. The shape of his face, all of this is determined by humans. Now, in today's world, dogs cover every corner of our planet, every inch of the planet. You can't go anywhere in the world and not find a dog. And that is a result of humans. Our choice to selectively breed these animals has changed the face of our planet forever. Now, when Charles Darwin said, "Only the fittest survive," he didn't necessarily mean the strongest. He used it as the Old English term. Those that fit their environment the best are more likely to survive. And it's because of this that the world is full of countless diverse and incredible species, all of which are specially adapted to their environment. It's because of evolution that the world is such a beautiful place. I'm Damon Scotting, and this was Astronomical.
How would you like to have your name spaghettified by a black hole in front of thousands of people at the end of every single episode? Well, now's your chance. Astronomical is produced just by me, which means the scripts, recording, editing, social media and costume design are all done by myself. and after the first 2 seasons, the budget is basically empty, which is why I'm now looking for donations towards the future of this science documentary. And they start at as little as £1. If you want to watch your name be annihilated by a star as it swells into a giant before going supernova, then you can do so for as little as £1. Or, if you'd like to watch your name be ripped apart into its individual atoms by a black hole in a process known as spaghettification, then you can do that for just £5. And then finally, for just £10, you can take your place amongst the stars where you belong, because anyone that donates to science is a superstar. There we are, and if you can't donate at all, that's completely fine. Just make sure you like and subscribe, because that also goes a very long way. Cheers.